Hello everyone, and today we'll be seeing one of the problem from Geeks or Geeks. It says kth element of two arrays. So problem is pretty straightforward, that we are given two sorted arrays A and B and an element k. The task is to find the element that would be at a kth position of a combined sorted array. So if we are given two sorted arrays A and B in this example, and k is 5, so the final sorted array would look like this, and the fifth element would be 6 over here. So in short, they are asking us to find fifth smallest element within two sorted array. That's the only case. Same goes with second example as well, where the output would for sixth smallest element would be 10. So there are 6 elements and this is the 10th. Cool. There are multiple ways you can do this. One can say that, hey, I don't want it to do such kind of optimization. You can go ahead and just dump this array into another, dump both of the array and then combine. Else someone would say, I'll use two iterators to go ahead one by one. But yeah, that's not what we are here for. We are here to understand, can we do better? One thing is, we are given a sorted array. Can we optimize? Can we use that for our benefit? That's the thing which we wanted to ask. So these are two arrays which we are provided, and given k is equal to 5. So how can we deal with this? So you see, arrays are sorted. So that means once you combine this array, it would look something like this, which is this. And here we will find out that, hey, this is array A, this is array B. We'll tell this came from array B, this came from array A, this came from array A, this from B, and this from A. We don't need rest because we are done. 5 elements we got it, and these 5 elements what we got was from A, B combined. So the idea here is, we don't know how many elements would be there from A and from B. So can we do one thing, that can we go ahead and optimize this solution so that we can understand that, hey, how many elements we are getting from array A and array A number and array B number, or I'll say how many number of elements. Okay, number of elements from A and B, both I can get to know. Cool. So what better I can do if I got this number? So if I got this number, how many numbers I can get? Then I can understand that, hey, the next I'm starting at a terminal point at this point. Like, let's say if I'm having 3 elements from A, so I'm starting at this point where I have 3 elements from A and 2 elements from B. I know my element, my kth number, which is fifth number, would be residing over here or here, and that would be a simple O of 1 operation. So once done, check out the kth element. This is O of 1 operation. Finding number of elements, how can we find it out? So again, the arrays are sorted, and finding operation. Okay, finding operation doesn't take much time, it will take log n time. Again, what is the expected they want from us is minimum of A and B. So from minimum of A and B, so we can understand that, hey, either we can pick A or B based on size. So whosoever size is less, n is equal to minimum of length of A comma length of B. We can take that. In short, if I want array A to be smaller, I can just say that, hey, if int nb is equal to b dot length and int na is equal to a dot length, if nb is smaller than na, then I'll just return kth element of pak. So I'm making sure that A is small when we are at line number 23, and if A is small, just operate on A. What operations we wanted to find? That number of elements we wanted to get, how many elements. Still the question is same, again remains same. If I get a cut, like I'm cutting the array, right? I'm getting few elements from A and B. At what position I can get cut? There are few open questions. What position do I cut? And how can I ensure the cut is valid? So these are two very valid questions one can ask. And again there is one question, that how to make sure what elements to pick around cut. This is also a good question, although if you heard it well, this question is already answered. So if I'm cutting at this point, what element should I pick? Left hand sides, right hand sides, or the array A's, array B's element? What should I pick? So we'll answer step by step each question. What position do I cut? Frankly, I don't know, but all I know is I can cut within the array A. Now in this case, array A is this one and array B is this one, because we are operating on smaller array. Good for us. So if we are at 0th position and we are at NA is here, either we can take this amount, like either we can have cut in the way here, which says take 1/4, or we can take cut here, which means that hey, take take all the elements from here. So yeah, either of way works for us, but right now we don't have any idea where to cut, what position to cut. How can I ensure the cut is valid? How can I ensure that your cut is valid? Because you don't have just one cut. If you had one cut, every cut is valid, but you have two cuts. You just need to make sure that hey, these elements on the left hand side elements of A and B combined comes on to the left when right hand side elements of A and B combined. What do I mean by that is 4 should be less than 7 and 6 should be less than 8. That's it. So if I don't know how to cut, what strategy should I use to cut? Just use binary search, man. Just understand that hey, can I cut in the middle? Maybe yes, maybe not. If yes, then go ahead. If I cannot, check on the right hand side, left hand side, and so on. And how to make sure the element is picked around the cut, I'll let you know in a while. So first of all, let's have binary search L A or let's have it L, which would be initially 0, int R is NA. Again, there's a catch over here to do. Understand the limits. So I'm just writing for now 0 and NA, and we can discuss this later. So actually, do we want 0? What if our K is, our length of first array is how much? 1, 2, 3, 4, and our K is 7. In that case, we have to pick all the elements from A. So it would be somewhere maximum of what we're saying 0 or n A minus K. And minimum of NA comma K here, because at least we want K elements from this array, and minimum we can go to NA minus K, that hey, either we want 0 or nothing, like that sort. So yeah, with that keeping in our mind, we can get started. So while L is lesser than or equal to R, I can say int mid, or I can say cut 1 or C1. C1 is just for cut 1, Just make it bigger. Yeah. So C1 is equal to L plus R minus L divided by 2. And if C1 is made on this point, at what point C2 can be made? Obviously, we have k elements, right? We need to fulfill k elements. If I'm filling 2 elements right now, how many elements should I fill later? It's k minus 2 or 5 minus 2, which is 3. So k minus in C2 is equal to k minus C1. That does make sense, right? Cool. So with this thing in mind, we had our cuts ready. And how should we proceed further? If we have our cuts ready, then let's understand what are the values around cut, a left value and right value between C1 and C2. So I'll say C1 left and C1 right. Similarly, C1, C2 left, C2 right. Let's take C1 left. How can I get the left? I can just go ahead, make A, because C1 is for A. C1 minus 1. That's fine? Yeah, that's fine. But what if C1 can equal to 0? Yes, that's possible. And in that case, we need to not go within negative indexes. So integer dot min value is the best thing to do. If this, then this. Else C1 is equal to NA. In that case, integer dot max value. That means no number beyond this point is maximum. So A of C1. Just doing that. C2 left, similar thing. C1, what we did with C1, integer dot min value. But in this case, we are taking with B, B2 minus 1, C2 minus 1 for B. C2 is equal to NB, integer dot max value for B, C2 minus C2, yeah. Now we have left and right. In ideal scenario, you know that C1 left should be less than C1 right, or equal to, maybe, because the limits can be same, or C2 left can be less than or equal to C2 right. In this case, it's a perfect thing, but here we want partitions to be perfect. So C1, C2, C2, C1. So C1's left, what I mentioned over here is C1's left should be on smaller than C2's right, and C1's right should be greater than C2's left. So that's the only case, and that means we are on the perfect side and we had a cut. And if we had a cut, we can return the answer. But wait a second, where does the answer decide? Now you had a cut, right? You had a cut, you had left hand sides. I'll tell right here. You had left hand sides, also you had right hand sides over here. At what position you think it would be best fitted? Because you have all the elements on your left hand side. 5 elements you wanted, 5 elements are on your left hand side. You just focus on your left hand side then. So return left hand side. So wait a second, C1 left or C2 left? You see, you wanted a maximum element because you wanted the last element. The last element is a maximum element. So I'll take a max from both of them. If that is not correct, maybe if that is not the case, maybe C1 left can be greater than C2 right. So that means we are on higher side of C1. Get low, and you wanted to get low, so then just go for R is equal to mid minus 1. Else L is equal to mid plus And ultimately we can just go ahead and return -1, although -1 this condition would never occur because k is valid and the arrays are also valid. Anything here? Understand this limits. So the limits is left and right. Right is quite common, that hey, how many elements do I need to pick? So do I need to pick the entire array? Is that my limit, or is my limit only k elements? So in this case, if the array would not be of the size this but 100, 101, 102, 103, and similarly size b also increases, so on. So let's remove this for a while and let's understand this array. So do I need to pick the entire array? Maybe the array length can be 1000. Do I need to pick that? No, I don't need to pick that. I just want 5 elements. So maybe the 5 elements come from entire this array, or 2 elements come from this array. What is the maximum value that can come from this array? This is the 5 elements, because we want 5 elements. We don't care it has 1000 elements. We just want 5 elements. So we want 5 elements, that is k, or the size of element, whatever is the minimum. So that's the reason we took it over here. Also there is L, which is mat.max of 0, not na minus 1. It would be a negative number. Okay, k minus na. So what would be the maximum of this? So you see, if k is so huge that we wanted few elements, it's not n, nb. So k is so huge that we want within this array itself. Okay, I have damaged the array. Within this array itself, A has how many elements? A has 5 elements, and here A has 4 elements. Within this, we want, let's say, 8th element. In that case, can I go ahead with L as 0 within the here? Let's make it A and B. Can I go ahead with 8th element to have a lower bound of A as 0? No, you cannot have, because 5 elements are right from B. You need to have at least 3 elements from A. So that's the reason you can have at least 3 elements or 0 elements. Whatever suits best for me. 3 is best for me because I know for sure it's a pre-optimization thing. No need to worry about that a lot. You just are fixing the bounds that, hey, I don't want it to go beyond this bounds. And bounds are very notorious for binary search. So yeah, this was the logic. I hope I have answered these questions. How can I ensure, how to make sure what element to pick around the cut? Yeah, we made sure. What position do I cut? We just went ahead with mid position, and then we optimized it based on how can I ensure its cut is valid. If it is not valid, pick the next cut. So cool, let's compile this code for any compiler errors. Oh, there are few. LNR mid cannot find symbol. What mid? It's not mid, it's C1. We are treating C1 as mid. My bad. Sorry, I'm a bit under the weather. I hope you understand. So yeah, case compiled. Let's submit this, and yeah, it works for rest all the test cases. This is a very good problem for binary search, and we respected the time complexities as well and space complexities. So this was all about kth element of 2 arrays, a part of a binary search. For more binary search related content, click the video on your right, and I'll see you in the next one.